Hello everyone. We will now work through the solution of question number 2 on project 3, which is on the application of the sum and difference identities. The question says, find the exact value of the following under the given conditions. So the conditions are given next to each question, but we have given you the different sum identities here, and you have to find the cos of alpha plus beta, sine of alpha plus beta, and tan of alpha plus beta. I have also written out the formulas for each of these sum identities. Cos of alpha plus beta equals cos alpha times cos beta minus sine alpha times sine beta. Sine of alpha plus beta will be equal to sine alpha times cos beta plus cos alpha times sine beta, and for the tan of alpha plus beta, it's tan alpha plus tan beta divided by 1 minus tan alpha multiplied by tan beta. The conditions given to us is sine of alpha is 3/4. So the sine ratio of whatever angle alpha may be is 3/5, but alpha is in quadrant 1. They have given that condition. Alpha is a first quadrant angle, and sine of beta equals 5/13. Beta is a second quadrant angle. And with this information, we have to find the ratios of cos of alpha plus beta, sine and tan as well. Now, the way to go about it is find the sine, cos, and the tangent ratios of both alpha and beta. They've just given us the sine of alpha and the sine of beta ratios, but it's best to find the cosine as well as the tangent ratios for each of these angles, alpha and beta, because as you can see, the formula will need the cosine of alpha, cosine of beta, tan of alpha, and tan of beta as well. In order to find the cosine and the tangent ratio, let's find the values of x, y, and r, and then we can put together the ratios of each of the functions using their formulas. So on the side, let's find the values of x, y, and r for alpha first, and then for beta. So I'm going to work here on the side, but recall that the sine ratio has the formula y/r. The numerator of the ratio is the y value and the denominator will be the r value. And it says alpha is in quadrant 1. We will know the values of y and r, but we have to find the value of x. Y will be equal to 3. So we are just working on alpha, right? So therefore, just focus on sine of alpha equals 3/5. Don't worry about sine of beta at this point. X is what we have to find. Y has a value of 3. How did I find that out? By just looking at the ratio. Sine is y/r, so 3 is the value of y, and 5 is the value of r. So let's write that. R equals 5. Now to find the value of x, we will use the Pythagorean formula, which is r squared equals x squared plus y squared. Therefore, x squared will be equal to r squared minus y squared. R has a value of 5, so it will be x squared equals 25 minus 5 squared is 25. Y is 3, so y squared will be 9. So x squared equals 16. Therefore, x will be equal to square root over 16, which will be 4. Now, will it be a positive 4 or a negative 4? For that, we have to look at the quadrant in which alpha is. Alpha is a quadrant 1 angle. Their x, y are positive values, correct? Therefore, we will just leave x as a positive 4. If the angle were in the second quadrant or in the third quadrant, x would be negative. So you have to keep that in mind. You have to think about that. Because it's a first quadrant angle, x is a positive value, positive 4. So based on this information, we can put together the sine, cosine, and the tangent ratios. Let's write that here. Sine of alpha, that's already given to us, is 3/5. Cos of alpha will be x over r, therefore 4/5, 4 over 5. And tan of alpha will be equal to y over x, so 3 over 4. Let's find the ratios for beta now. Now beta is a second quadrant angle, so we have to factor that in after we find the values of x, y, and r. Alpha was a first quadrant angle. Let's write that down. What is the ratio given to us for beta? Sine of beta is 5 over 13. Therefore, I will write x equals, we don't know, we have to find that out. But y has a value of 5 and r has a value of 13. Again, same formula. X squared will be equal to r squared minus y squared. Solving for x squared from the equation r squared equals x squared plus y squared. That's how I got this step. I skipped this step. I went straight to solving for x squared. X squared equals r squared minus y squared. Let's plug in the values. R squared is 13 squared. Y squared is, y is 5, so it's 5 squared. Therefore, x squared will be 169 minus 25, which will give us a value of 144. Therefore, x will be square root over 144, which is positive 12. However, this is a second quadrant angle. In the second quadrant, x will be a negative value. The second quadrant is along the negative x-axis. Therefore, we have to make that a negative 12. So I'm going to write negative 12 for x. Now let's write down here the values of sine of beta, cos of beta, and tan of beta. So sine of beta is already given, so that's 5 over 13. Cos of beta is what we have to come up with. It's negative 12 over 13. X divided by r, correct? So negative 12 over 13, and tan of beta will be equal to y divided by r, so 5 divided by negative 12, which is negative 5 over 12. Now we are ready to find the values of cosine, sine, tan of alpha plus beta. Let's start with the cosine because that's the first one they asked us for. Let's write the formula first to make things easier. Cos of alpha plus beta has the formula cos alpha times cos beta minus, for the sum formula there's a minus in between the two terms, minus sine alpha times sine beta. What is the value of cos of alpha? It's 4/5. So 4 over 5. For cos of beta, it's negative 12 over 13. So negative 12 divided by 13 minus sine of alpha is 3/5, 3 over 5, and sine of beta is 5 over 13, which gives us negative 48 over 65. So 4 times negative 12 is minus 48. 5 times 13 is 65. So we have minus 48 divided by 65 minus, for the second term, it's 3 times 5, 15 divided by 65. And then when we complete this subtraction, minus 48 minus 15 is equal to negative 63 divided by 65. That's the answer for cos of alpha plus beta. Cos of alpha plus beta is negative 63 divided by 65. That's cos of alpha plus beta. Now we have to find sine of beta. Again, first write out the formula. It's so much easier and helps you from making careless mistakes, right? So I'm going to write sine alpha times cos beta plus cos alpha sine beta. And then just plug in the values, all right? So sine of alpha is 3/5. Cos of beta is minus 12 over 13 plus cos of alpha is 4/5 and sine of beta is 5 divided by 13. Let's complete this addition. First, we have to multiply the values. So 3 times negative 12 is negative 36. Denominator is 5 times 13 is 65, plus 5 times 4 is 20 divided by 65. When we complete this addition, minus 36 plus 20 is minus 16 over 65. And that's the answer for sine of alpha plus beta. So now we have to find tan of alpha plus beta. Let's write out the formula again. It's tan alpha plus tan beta divided by 1 minus tan alpha multiplied by tan of beta. In the numerator, it's addition. In the denominator, it's 1 minus tan alpha multiplied by tan beta. The two tans get multiplied in the denominator. In the numerator, they get added. But in the denominator, it's 1 minus tan alpha times tan beta. Let's plug in the values for tan alpha plus tan beta. So tan of alpha, what was it? It was 3/4. So 3 over 4 for tan of alpha, plus tan of beta was a negative value. It was negative 5 over 12. And then in the denominator, we have 1 minus 3/4 times tan of beta is negative 5 over 12. So let's take care of the numerator first. When we add the numerator, there's a minus 5 over 12. So we'll end up having 3/4 minus 5 over 12. That gives us minus 15 over 48. When we complete the addition. And then in the denominator, it's 1 plus 15 over 48. How did we end up with a plus when we had a minus to begin with? Because there's a minus 5 over 12. When we multiply that by 3/4, we end up with a negative quantity, and then that minus the minus will give us a plus. That's how we ended up with 1 plus 15 over 48. So now let's continue below here. We have minus 15 over 48 in the numerator. In the denominator, 1 plus 15 over 48 gives us 63 over 48. And then the 48 will divide, and we will be left with minus 15 divided by 63. All right, let's box this. That's the final answer for tan of alpha plus beta. Therefore, the final answers after all this work is cos of alpha plus beta was negative 63 over 65. Sine of alpha plus beta was negative 16 over 65. And tan of alpha plus beta is negative 15 over 63. So this is the process you must follow in order to work out these problems on the tests as well, because unless you show these steps, you will not be awarded full credit for the question. First, find the values of x, y, and r for each of the angles alpha, beta. Remember to take into consideration the quadrants that the angles are in. It should say in the question itself. Based on that, you will assign the appropriate signs to x and y. And then it's best to find sine, cos, tan for alpha and beta. Because if you have that up front, it's easy for you to plug in the values. Always write out the formula first, even though you may have it up there somewhere. But when you're working through it, it's better to have it in front of you. Again, it'll help you plug in the values correctly, perform the addition and multiplication and subtraction, whatever you need to do correctly, division as well. These are all fraction addition and subtraction for most of the time. And then once you complete that, you will get your answers. All right? The next couple of questions are pretty similar to question number 2, for which I have shown all the steps. Please follow those steps to answer the next 2 questions. However, I will give you some of the answers at the different steps. So for question number 3, it says sine of alpha equals 4/5. Alpha lies in quadrant 1. Sine of beta is 7 over 25. And beta lies in quadrant 2. So the first step will be to find the values of x, y, and r for both alpha and beta. I'm going to give you the values of x, y, and r that you should be able to find correctly for alpha and beta. So for alpha, x will be equal to positive 3, y will be equal to 4, and r will be equal to 5. For beta, x will have a value of negative 24, y will have a value of 7, and r will have a value of 25. Now, given this, you should be able to put together the ratios. Sine alpha would be y over r. Y would be equal to 4 and r would be equal to 5. So y over 4 is 4/5. So sine of alpha, they've already given us the ratio, but cos of alpha in first quadrant would be a positive ratio. Therefore, that's x divided by r. So x divided by r is 3/5, and tan would be y divided by x, y over x. Y has a value of 4, x has a value of 3, therefore 4 over 3. Let's do the same for, and this is all for alpha. Let's do the same for beta. We'll have sine of beta equals, again, y over r would be 7 over 25. For cos of beta, it would be x divided by r, so negative 24 over 25. Now you may ask, why is x negative? Because beta is a second quadrant angle. In the second quadrant, x will be negative, y will be positive. That's why we put the negative sign to x. Tan of beta would be equal to y over x. That's 7 over negative 24. So 7 over negative 24, which can be written as negative 7 over 24. Doesn't matter. But the negative sign is really with the x. So these are the ratios. Now write out the formula and then plug in the values correctly and then do the calculations. Therefore, for cos of alpha plus beta, and these are all some formulas that you will be applying. For cos of alpha plus beta, the answer is negative 4 over 5. For sine alpha plus beta, the solution is negative 3 over 5. And for tan alpha plus beta, you should get an answer of 3 over 4. So these are the solutions. Please work all the steps clearly, space out your work so that you can get to the correct answer, because there are several calculations that you have to perform here. All right? Let's work on question number 4, which is similar to question number 2 and 3 that we worked before. I'm not going to work through the entire solution for 4. I'm going to just give you the answers for some of the steps in the process of solving this problem. So when you're working it yourselves, you can make sure that you're on the right track and your answers are matching with mine. In case it is not and you're not able to understand why, let me know. I will give you some guidance, or I can also check my answers to make sure that there's no mistyping or misprint anywhere. So the question says tan of alpha equals negative 3 over 4. Alpha lies in quadrant 2, and cos of beta equals 1/3, 1 over 3, and beta is a quadrant 1 angle. The process is the same. We will first find the values of x, y, and r for each of these angles, alpha and beta. In the process, we have to make sure that we consider the quadrant in which the angle lies, because that will decide the sign of x or y, as the case may be. So let's start with alpha first. They've given us tan of alpha equals negative 3 over 4. The tangent ratio is y over x. Now, it says alpha is a second quadrant angle. In the second quadrant, it's the negative x-axis. Therefore, x will have the negative sign. This negative sign will really be associated with x. So let's try to find the values of x, y, and r for alpha. So for alpha, x will be equal to negative 4, this being a second quadrant angle. Y will have a value of positive 3, and you have to use the Pythagorean formula to find r, which is r squared equals x squared plus y squared. you will get a value of 5 for r. For beta, we've been given the cosine ratio, which is x divided by r, and it says beta is a first quadrant angle. In the first quadrant, all ratios are positive, therefore we do not have to worry about the negative sign associated with x or y for beta, right? So x will have a value of positive 1, y will have a value of 2 times square root over 2. Using the Pythagorean formula, you will have to do the calculation, and r will have a value of 3. Now that we have the values of x, y, and r for alpha and beta, let's put together the different trigonometric ratios. Sine of alpha equals y divided by r. Therefore, it will be 3/5. Cos of alpha is x divided by r. That will be negative 4/5. We know that in quadrant 2, cosine is negative 4/5. And then for tan of alpha, it will be y divided by x. Therefore, 3 over negative 4, which can be written as negative 3 over 4. Again, you can just verify that in second quadrant, tangent is negative. Therefore, we have the correct sign for tangent as well as for cosine. Both cos and tan are negative for a second quadrant angle. As far as beta is concerned, everything will be positive. It's a first quadrant angle. Y divided by r would be 2 times square root over 2 divided by 3. And then we have cos of beta, which is equal to x divided by r, therefore 1/3, 1 over 3. It's given to us also in the question. And for tan of beta, it will be y over x. Y is 2 times square root over 2, x is 1. Therefore, 2 times square root over 2 is the value of tan of beta. Now, the next steps you have to work out yourselves. You have to use the correct formula to find cos of alpha plus beta, sine of alpha plus beta, and tan of alpha plus beta. Plug in the values correctly and do the calculations. Let me give you the answers for each of those. Cos of alpha plus beta, after you perform the calculations, should be -4 minus 6 times square root over 2 divided by 15. Sine of alpha plus beta will be equal to 3 plus 8 times square root over 2 divided by 15. And tan of alpha plus beta will be equal to 54 minus 25 times square root over 2 divided by 28. Now, for tan of alpha plus beta, towards the end of the calculations, you will have to perform some rationalization of the denominator and simplification to get to this answer, which is 54 minus 25 square root over 2 by 28. So I'm going to work through that process, the final steps of arriving at this answer from the process where you have to perform the rationalizing of the denominator. So let me walk you through those steps, all right? Because some of you may be a little bit rusty on how to perform the rationalization when we have a binomial expression, all right? So after you plug in the values into the formula for tan of alpha plus beta, do the calculations, you should arrive at an expression which is -3 plus 8 times square root over 2 divided by 4 plus 6 times square root over 2. Now this expression looks nothing like the answer that I've given to you. So you may wonder, how did she arrive with this solution, with this answer? So the way we go about it is we have to rationalize the denominator. You see, there is a radical in the denominator, and whenever we have a square root in the denominator, we need to rationalize it, get rid of the radical from the denominator. Now, because we have a binomial expression in the denominator, in order to square that up, we will have to multiply it by its conjugate. In order to do that, if you recall way back in algebra, we learned of a formula: a squared minus b squared equals a plus b times a minus b. So if we multiply the given expression by its conjugate, which is the same expression with the opposite sign. If it's a plus b, the conjugate of that is a minus b. If it's a minus b, the conjugate of that is a plus b. So if we multiply the binomial expression by its conjugate, then we can end up squaring both the terms. All right. So that's what I'm going to do here. I will be multiplying the denominator by its conjugate, which would be 4 minus 6 times square root over 2. And whenever I do that, I have to multiply the numerator by the exact same expression that I multiplied the denominator with. So 4 minus 6 times square root over 2. Let's take care of the denominator first because that's relatively easy. All you do is square each of the terms. 4 squared is 16, and we have to square 6 square root over 2. So 6 times square root over 2 squared. You have to square 6. You have to square root over 2. So we'll get 36. 6 squared is 36. And square root over 2 squared is 2, correct? So 36 times 2, we have minus 72. The formula is a squared minus b squared. Therefore, we have to write 16 minus 72. Now, what happens to the numerator? For this, you have to use the FOIL method and multiply it out. So again, I'm going to do the steps here. All right. It's best to write out the FOIL here. We have radicals in both the expressions. It will not be easy to do it in your head mentally. Work it out step by step. It is a lot of work for this problem, but at least it'll be easier for you to arrive at the correct answer and not make mistakes. All right. I'm writing out the FOIL at this step. So minus 3 times 4 minus 6 square root over 2. And then we have plus 8 times square root over 2 times 4 minus 6 times square root over 2. Right? So we have minus 12 plus 6 3s are 18 square root over 2 plus 32 square root over 2 minus 8 6 are 48. And square root over 2 times square root over 2 is square root over 4. Correct? So square root over 4 can be written as 2. So I'm going to erase this and just write 48 multiplied by 2. So what do we have here? Negative 12. Now 18 square root 2 plus 32 square root 2 is plus 50 square root 2. And then minus 96. 48 times 2 is 96. Minus 96. Now we can combine minus 12 minus 96 is minus 108 plus 50 times square root over 2. And that's the expression that will go in the numerator. So it'll be minus 108 plus 50 times square root over 2. And then in the denominator, 16 minus 72 will give us, let me complete the numerator first, 50 square root over 2. So 16 minus 72 will give us minus 56. Now, at this point, we have to simplify this further. From the numerator, I'm going to factor out negative 2. So we will have negative 2. And what do we have within brackets then? 54, correct? If we factor out negative 2 from negative 108, within brackets, we'll end up with 54 plus 25 times square root over 2 divided by negative 56. And then the negative and negative divide. What else divides? This 2 and 56 will divide to give us 28 in the denominator. And we will have 54. And we just made a mistake here, which I need to correct. I wrote 54 plus 25 square root over 2. If we pulled out a negative sign outside the brackets, this better become negative, right? This should have been a negative. It's my mistake. Let me correct this. This should be negative, all right? So we'll end up with 54 minus 25 square root over 2 divided by 28 is what the answer is. That should match with what I gave you here. All right. So I wanted to show you the final steps, which some of you may find a little bit challenging to get to the final answer for tan of alpha plus beta. For sine and cos, it's not as complicated, so I expect you to be able to work those out yourselves. All right?